we begin, let's start by defining and identifying some of the major components of a neuromuscular junction and muscle fiber. The sarcolemma is the cell membrane around an individual myofibril. The sarcoplasmic reticulum stores the calcium ions that are released during an action potential. The T-tubules are tubes filled with extracellular fluids that signal the release of calcium to the myofibrils. And the sarcomere is the smallest contractile unit of a muscle and is composed of microfibrils.
Next, we will describe the muscle fiber contraction process. It starts with excitation. This is when the neuron sends an action potential down the synaptic terminal. This triggers calcium to enter into the neuron via a transport protein. Then acetylcholine is released and enters the synaptic cleft and binds to the receptors on the sarcolemma. The receptors open sodium channels and sodium enters into the cell and potassium exits the cell, which causes another action potential in the muscle fiber.
So next, during excitation contraction coupling, the action potential is sent through the transverse tubules, causing the voltage-gated calcium channels to open in the sarcolemma, and calcium leaves the sarcoplasmic reticulum and diffuses into the sarcomeres. The calcium then binds to the troponin complex, which exposes the active site on the actin filaments.
During contraction, ATP binds to the myosin head, causing it to cock. The cocked head binds to the active site on the actin molecule, forming a cross bridge. The myosin head performs a power stroke, which moves the actin filament over the top of the myosin filament, resulting in contraction. The myosin head binds with another ATP molecule, detaching from actin, and becomes uncocked. The process repeats until the muscle is finished contracting.
Overall, the troponin-tropomyosin complex regulates whether or not myosin can bind to the active site. Cross-bridge formation allows the myosin to bind to the actin so that it can perform a power stroke. The power stroke is when the myosin is physically moving over the top of the actin. The myosin head must use ATP to cock to the head and attach to the active site, as well as be removed from the active site. Go.
Okay, during relaxation, acetylcholine is no longer released and is broken down by enzymes. This is the calcium is reabsorbed using active transport by the protein pumps in the sarcoplasmic reticulum, and calcium is removed by the troponin complex. So the tropomyosin covers the active sites on actin, and the contraction then stops.
ATP is needed in 4 areas of muscle contraction. The first is ATP is needed to run the sodium-potassium pump once the action potential ends, so that the sodium-potassium levels can return to normal. Without ATP, the sodium and potassium would not return to their normal levels that they were prior to the beginning of the action potential, so that another action potential can occur. ATP is needed also to cock the myosin head so that it can bind to the active site. Without ATP, this head would not cock and could not perform a power stroke. ATP is also needed to detach the myosin head from the tropomyosin complex so that it can perform another contraction. Without ATP, the myosin head would stay attached to the actin and would prevent another contraction from occurring.
ATP is needed to pump calcium back via active transport into the sarcoplasmic reticulum when the muscle contraction is ending. ATP is needed for the vesicles to release acetylcholine into the synaptic cleft. Without ATP, the acetylcholine would not be released into the synaptic cleft, so muscle contraction would not occur.
We picked the 2 scenarios involving dehydration and warming up exercises. When someone is dehydrated, they have less electrolytes like sodium and potassium in their body. Therefore, they would have less sodium and potassium available for action potentials, so their muscle contraction would be less efficient. When someone warms up their muscles before exercising, the contractions allow for more calcium to be available, leading to more efficient muscle contractions.
Thank you for watching.